Good day, class. This is your favorite chemistry tutor, your unstoppable manifesto. Now, in today's lesson, we are going to be looking at the oxidation number, okay? And rules for determining the oxidation number, all right? So before we proceed into the rules, there are so many rules, okay, that is used to determine oxidation number. But before we proceed, what is oxidation number? Oxidation number is the charge, okay, that an atom carries, okay, and this charge is gotten from a set of arbitrary rules. Now, that arbitrary rules is what we are going to be looking at in this class, okay? So, let's proceed. Now, the first rule in calculating or determining the oxidation number of an element is that the algebraic sum, rule number one, we have rule number one or rule one. The algebraic sum, okay, the algebraic sum of a neutral compound, okay, neutral compound or neutral, okay, molecule, okay, is equal to 0. Now, it is to say that if a compound does not have a charge, okay, the algebraic sum of that compound will be equal to 0. For example, we have magnesium chloride, okay, magnesium chloride. The algebraic sum of this is equal to 0. All right. Now, sodium hydroxide, the algebraic sum of this is equal to 0. All right. That is what rule number one is saying. Now, rule number two. The algebraic sum of a compound, okay, with a charge is equal to the charge. That is rule number two. The algebraic sum of a compound with a charge is equal to the charge it carries. For example, if we have MnO4 minus, okay, this will be equal to the charge it carries, which is -1. Are we together now? Now, if we have Cr2O72 minus, okay, the algebraic sum of this compound will be equal to -2. Are we together now? Now, if we also have SO32 minus, the algebraic sum of this compound will be equal to -2. Okay, that is rule. All right. So the rule number three, okay, or rule 3. Now, the oxidation number of a neutral atom, okay, neutral atom is equal to 0. The oxidation number of a neutral atom is equal to 0. What does it mean? If we have something like this, sodium, we have sulfur, okay, we have, let's say, chlorine, we have iron. Their oxidation number, these are neutral atoms or molecules. The oxidation number is 0, 0, 0, 0. Okay, that is rule number 3. Now, rule number 4. Rule number 4. The oxidation number of an ion is equal to the charge it carries. The oxidation number of an ion is equal to the charge. Is equal to the charge. For example, we have, let's say, fluoride ion, we have chloride ion, we have bromine ion, we have, let's say, magnesium 2 plus. The oxidation number of these ions we have here is -1, -1, -1, plus 2, dot, 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 dot. That is rule number 4. Now, rule number 5. Rule number 5. Rule number 5. Okay? Rule number 5. The oxidation number of oxygen. The oxidation number of oxygen in a compound is equal to -2, except in peroxide, except in hydrogen peroxide, except in hydrogen peroxide, where the oxidation number is equal to -1. Alright, so look at this now. We have, let's say we have H2O. Alright, this is water. The oxidation number of oxygen here is -2. Okay, is -2. Alright, why? All group 6 elements have the oxidation number of what? -2. Okay, and based on that, oxygen is what? Is found in group 6 of the periodic table. Alright, now but for peroxide is H2O2, hydrogen peroxide. The oxidation number of oxygen here is -1. We can actually determine or verify the charge for this oxygen. So this is what for oxygen is -1. Alright, so that is it.